everyone. Welcome to our session. It's Logical Data Warehousing for Advanced Analytics. A little bit introduction about us. I am Nagapriya Tirutani. I go by Priya Tirutani, and I'm with IBM, the SQL campus, which is in South San Jose. I'm the offering manager for Db2 Big SQL, and my co-presenter is Herbert Pereira. He's from Toronto, and he's with the Canada Labs, and he's our chief architect. So let's go into detail of the notices and disclaimers. That's what we are here to listen about, right? Just kidding. So let me walk through quickly about what we mean by logical data warehousing. So we are all at DataWorks Summit, and it's all about data. And data is like oil. It's useless if it is crude. So we do have to refine it and curate it to make it useful. And once it's refined, then you can have more analysis on customer behavior, their buying patterns, their sentiments. So the businesses can offer customized coupons or offers for them to benefit from. So for the business to have this deep insights, they need to have the whole enterprise data accessible and derive their insights from it. So just having a silo database and querying against it is not going to get you that, because data comes in various forms and at various pace, and then you have to analyze that data. So that's the business end. But the customer is also demanding more personalized coupons and offers. Gone are the days where we used to save our newspapers or booklets to save the coupons. Remember to take it to the shops and use them. Now everybody with our smartphone, we want everything given to us. So some of the innovations that's happening is the location-aware capability. Here we have an example where Starbucks recognizes where the customers are, and based on their location, it's able to identify which is the closest Starbucks available and is able to personalize the offer for you to go to their store and buy the drink that you would like to have. And also, then we have Uber that's revolutionized the transportation industry. Not only that, but now they are going into the food delivery industry, and all this is possible because they're able to collect all the geolocation data, the driver's location, and the needs of the customers as well. And the other interesting industry that's revolutionizing here is the healthcare. So now with this Babylon application, the patients can demand to talk to a doctor or visit the doctor when they want to, rather than trying to set up appointments and going to the doctor's clinic. But the demand for the patient to meet the doctor is at the customer's end. So how can we make this all possible, make our customers happy? So that's where the game has been changing, right? So the data is not just flowing into one database, but the data is flowing from different places. So it's no longer relational, and now the data is coming from your social activities, your clickstream data, then from your mobile data, and also from your sensors. So it's coming in all forms and formats, and it's coming at a faster pace. So you need a way to store all the data, and with the volume and the velocity that's coming in. That's the data aspect, but then what do you do with the data? Now you need to analyze the data. So there is a need to do advanced analytics and do some self-discovery to bring some value to your customers. This not only brings the capability of being able to read the data and analyze it, but also keep the data secure. So all these aspects of data is changing the whole way the industries has been moving on. So this is from Gartner, and this was published in 2017. So Gartner recognizes there are three development stages where you do analytics. So one is the classic traditional data warehousing, where you have relational data stores. It's all structured data, and the applications demand the way your data store is defined. So you have an agreed upon data model, and you have the quality of data defined. So, and it also enables you to have many concurrent users going against it. But then you have smaller teams that are kind of exploring new opportunities. And how do they go about it? They just start up a new open source database. They bring in some data that they think that might be useful for their new apps, and they start building the apps. So here they bring in data from their different data stores, and they kind of duplicate the data, and they go against it to find new opportunities. And the third aspect is where you build a data lake. So data lake is where all your non-structured data, unstructured data comes in, and you try to find new capabilities or new insights into the data, and also try to understand the data, because it's all in different formats and it's also kind of very raw. But though each of them have their own aspects, but that's not all. For a business, you need to take a step back and look at it as a whole. All these three development styles are not complementary, are complementary, but they are not like one or the other. So you do need to bring all these different data sources together to have deeper insights. So let's double click into the Hadoop environment itself. So earlier, when Hadoop started off, we used to do analytics directly on Hadoop, but that did not give us the performance that we need. The BI tools were were very slow, and it was throttling. So then we went to the 3-tier architecture, where we had all the raw data in Hadoop. Then we curated the data and moved them to data marts and did the analytics against the data marts, which gave you a reasonable performance. But what this brings is duplication of data. Your data pipeline becomes much more complicated to handle, and with the fast changing data, it's harder to keep it up to date. And all these experiences have evolved into the logical data warehouse architecture. So here you have your Hadoop environment, you have your relational data source, you have your NoSQL data source, and now with all the cloud storage available, you have your object stores as well. And that's when you bring a single entry point that lets you integrate the different data sources and also manages your metadata in such a way you can go against all these different data sources. And your analytics layer connects to that single layer, and it's able to access all the different types of data. So when you consider a logical data warehouse, what are the things you need to consider? So one is uniform access. You want to go against all the data, but you do not want to move the data. You want to read the data where it resides. And you want to have all the metadata defined centrally. You want to have all your schema definitions, your permissions and access privileges all defined in your central place, and it's uniform across all these different data sources. And then comes the performance. You want to make sure the performance is, you have low latency when you execute your workloads, your queries. So parallelizing your processing gives you that. So you have to ensure that your execution is parallelized. The other important aspect when you're considering a logical data warehouse is to make sure that you are data source agnostic. You can't define, I can work only against this kind of data source or that. You need to make sure you go against all the different types of data sources. And then comes with all these different data sources, you want to know who's accessing it, why they're accessing it, what has been changed. So you want to understand the data lineage, and also you want to ensure that the good performance that you get with that. And then the agile enterprising is where your data sources, you started off with something. You thought this is what you're going to go with. But over time, you realize that this is not what you want. You might retire some data sources, or you might acquire a company which has a totally different type of data source that you've never had in your enterprise. So you need to bring that in, and you need to start making sense of that data that it brings in. So having ability to have an agile enterprise is one of the key things that the logical data warehouse offers you. And then, of course, all this is nice and good, but then data has to be available at all times. There should never be a downtime. So there should be a single layer that's able to provide you the data that you're looking for, and also have a centralized administration that lets you go and monitor and give access to people who want to look at the data. So this is where I want to introduce you to Db2 Big SQL. So this is a SQL engine that sits on Hadoop. So it goes on top of Hortonworks data platform, and it's one of the services that's installed in your cluster. And what Db2 Big SQL lets you do is run all your queries and your workloads against these different data sources that's down there. So it can query the Hadoop environment, Hadoop clusters, it can go against your object stores, it can go against your relational data sources and also your NoSQL data stores. And immaterial of what your application layer is, be it mobile, web, or your BI tools, it can all point to Db2 Big SQL, and that can be your single entry point. And then I want to emphasize here Db2 Big SQL because we brought the intelligence of Db2 to the Hadoop environment. So let me summarize the advantages of having this access. So having the ability to query against all these different data sources gives you an ability to extend your data warehouse, and you want to enrich your data with the data sources out there. And also it lets you prototype new applications easily rather than moving data and making sure that's the data that you're looking for. And of course, like I touched upon, with mergers and acquisitions, there's always new data sources, new data types, new formats of files that you want to bring in, and you want to be able to query and make some business decisions that has been acquired. It also enables you to have business integration by having real-time and targeted access to your databases. It also lets you consolidate or make sure it's highly available. And the other thing is your warehouse augmentation. So your traditional data warehouse is running out of capacity. So do you invest more on your traditional data warehouses, or do you want to offload your cold data and make more room for the new data that's coming in? Or traditionally, the archiving was done on tapes, which was not queryable, but now with Hadoop that's even possible. So you just offload to Hadoop, and the data is right there, and whenever you want to have a deep analysis or deep reporting for years of data, you can go against the data that's on Hadoop. And of course, new discovery. So with all the AI and the machine learning that we're hearing about, discovery is always happening, and the rich data sets is what defines the kind of AI or the machine learning that you can bring about in your business. So with that, I'll hand it off to Herbert, who's going to dive deeper into what Big SQL brings into this whole logical data warehousing.
Just do, okay. Yeah. Hello, everyone. Just keeping my timer here. So thanks, Priya, and thanks for the opportunity. To be perfectly honest, I wasn't sure I was going to make it to San Jose with. I work in Canada, and with Donald Trump now getting along with Justin Trudeau, I thought they were going to stop me at the border, but I think a few of us managed to get across. So discussing with Priya earlier in terms of what content to put on the slides and talk about, I'm an engineer, so I think I went too low level in terms of the details that I wanted to share with you, and I lost the debate. Most of my slides ended up in the backup section. No, just kidding, but I'll bring them forward if needed, depending on where the conversation is going. So in terms of the time that we have, what I wanted to do is really share with you the journey that we've been in with our particular offering, which from an engineering perspective, we've started to think more as a platform, not just a product offering. And it's a journey that started a few years ago, and it has evolved over time in terms of realizing a data virtualization solution that is very timely if you look at existing warehousing solutions today, more specifically in the Hadoop space. So we started off actually 5 years ago, if I recall correctly, talking about data warehouse augmentation. And the idea there was to take your traditional, relational in most cases, data warehouse solution and be able to give your users access beyond the data warehouse, access data that lives in other repos, in other data marts, possibly in other systems that are part of your IT ecosystem. So we started off with a vision about federation. We called it federation. So the ability through data connectors to be able to access those other data repositories. And we started off with the traditional systems, the Oracles, the Teradata, the Netisas, the DB2s. Over time, we started building additional capabilities. Cloud became very important, segregated storage, object store, so we added support for S3. Our customers, interestingly enough, started experimenting with different, what we call deployment models. So today you can deploy the Big SQL service natively on your Hadoop cluster, directly on your data nodes. That is sort of the more traditional, the more pervasive installation mode. But some customers are installing on a subset of the data nodes, right? And there are other customers that are installing the service on none of the data nodes. That's what we call an edge node installation. And there are customers right now experimenting with edge clusters, when you actually deploy a cluster separate from your Hadoop data lake, and you point at it from that external cluster. So we looked at technologies like WebHDFS to provide that capability. So slowly but surely and gradually over time, we started building really a virtualization layer around Big SQL, which brings us to where we are today and to the capabilities that we have today. We're certainly not done. We don't think that the job is complete, and I'll touch later on a bit about our roadmap and our vision of data virtualization going into the future. So I wanted to share with you a bit of our journey, talk about some of the challenges our customers are having today and how the technology helps them address those challenges, and as I said, give you a glimpse of the future in terms of where we're going. So looking at again, the value proposition of data virtualization. If you're going to implement a logical data warehouse, and if you look at Gartner talks about different architecture patterns, talks about repository, talks about data virtualization. Certainly our view is that sooner or later you're going to have to implement a data virtualization layer. I mean, it is a core component of any logical warehouse implementation. It's all about providing shared access to all of your data, right? And it needs to be transparent for obvious reasons. Your business users, your applications need to be able to write applications against the data without having to be concerned as to where the data resides. Obviously, given the complexity of these ecosystems and the number of data repositories out there is heterogeneous by definition. All of these data sources have high function. I mean, they have properties, they have functionality that ideally your virtualization layer should be able to exploit. Right? At the same time, they have limitations, and you need to keep those in mind as you execute the query plans. And we touch on that briefly later. Autonomous, this is very important, and people often forget about this. And it is really, the concept is about being able to access those remote data sources as if you were just a regular user, right? The DBA or the system administrator doesn't have to take an outage or do anything out of the ordinary to accommodate the virtualized access to that particular data source. And at the end of the day, last but not least, if it doesn't perform, it's not useful. So we'll be spending some time on sort of the tools and the techniques and the technology behind making your data virtualization solution highly performant. This is a different view of kind of the same paradigm. In the top shows the traditional RDBMS data sources. You have the Big SQL platform in the middle, you have the storage underneath, and the storage is important because I'll be touching on what we're using the storage for. Storage is obviously your data storage. You have a data lake, an implementation of a data lake. You have other services that you leverage in your data lake. You can access remote data lakes through WebHDFS interfaces, but you can also use that storage for some interesting functionality, which I'll discuss briefly later. For example, caching, that in our view plays a fundamental role on any data virtualization solution. And Spark, we've invested heavily in Spark integration because Spark really frees the traditional relational database management SQL engines, whether it's on Hadoop or not, from some of the constraints associated with tight integration with storage, and it gives you the additional level of functionality and flexibility. So it allows you to access, for example, NoSQL data sources instead of us investing on new data connectors for this data sources, and there's a vast number of them out there. You can look at, we can actually leverage today the rich set of Spark connectors available, and then it allows you to expand your functionality into areas like machine learning. So this is probably one of the most fundamental aspects of any data virtualization solution. At the end of the day, we are focused on SQL access, right? And at the end of the day, your SQL has to perform. And that means that you need compilation and optimization technology that will build the right query plan, whether it's against your local HDFS data on your data lake, or it's across what we refer to as a constellation of data sources. The reality is that customers have from just a handful of heterogeneous data sources. We have customers are working with customers that the number of data sources goes into the hundreds. And then on the other side of the spectrum, you have IoT. And for all of them, certainly the query plan, the optimizer flow is very similar. If you look at our optimizer flow for HDFS access, is very similar. You start by parsing the query, you apply query rewrite rules to that query, and then very importantly, you make decisions. Essentially, the optimizer will pick from a number of different possible plans of execution, right? And very important to that decision making is being able to cost each of the plans appropriately. And costing is done through by looking at statistics. And in the case of a data virtualization solution, it's not just statistics about the data. It's also statistics about the constellation of data sources, network costs, right? What if you have geographically dispersed data sources? All of those considerations need to be taken into account to allow the optimizer to pick the most cost-effective plan. And there are a number of different techniques. I'm not going to go through all of them, but this is just a quick sample, and I'm short for time, so I'm going to start moving fast. For example, you have to make decisions as to what are the query operations that you're going to push down, right? You have to be aware of what are the operations that your remote data sources support, right? This is a simple example of account start, where we are essentially speculating there's a source that does support the count start function, but there's another one that doesn't. So the optimizer has to be smart enough, has to have the information about that data source, understand what are the operations that it supports, and if it doesn't, then to rework it in a way that you're still able to access the data that you need to complete execution of the query by accommodating, as I said, I talked earlier about the high function of the data sources, also the limitations and the specifics of each data source. Another example is often we talk about, and this is very common in the Hadoop space, the idea is about pushing the function to where the data resides. You want to take advantage of data locality, you want to minimize the I/O, which is the most costly portion of the operation. And when you look at virtualization, that is just as important, right? And often we talk about, well, trying to push as much as a function down to the data sources into your constellation. But there may be cases, there may be scenarios where that is not necessarily beneficial. And this is a simple example of two Oracle tables where the optimizer will look at the cost of bringing all of that data, all of those tuples back across the network versus just bringing the two data sets and doing the join or the aggregation on the front end of your data virtualization. So this is all different aspects that need to be taken into account within the optimizer. Our view is certainly that without that compilation and optimization technology, you can't have really an enterprise level data virtualization solution. I'm going to move quickly. This is about Spark, really. I talked about Spark earlier, and we've invested heavily in this area, tight integration with Spark, because again, it sort of frees the data warehouse and the traditional SQL technology from some of its limitations, and it allows us to do all sorts of interesting things, like schema discovery, machine learning, take advantage of caching. So there are all sorts of capabilities in addition to those additional connectors that I talked about that you can get through Spark. So I'm not going to spend much more time on this. And this is really a summary of, quick summary of sort of the capabilities we talked about. So obviously, in its, at the very basic level, you need the connectivity to be able to reach those remote data sources. You need to have the query capabilities for your queries to be performant, really to be functionally correct. I mean, if you're pushing functions to an Oracle server and you're sending SQL that the Oracle server doesn't support, well, your query is going to fail. If you don't know that ahead of time and your front end doesn't catch those discrepancies, then you're in trouble. Obviously, and I pre-attached on this, you need the ability to monitor. Probably one of the most often questions that we get from our customers is really, help me figure out what the heck is running on my system. It's chaos, right? Help me bring that chaos under control. Help me understand what's running, who's running what are the costs of the queries, what's the performance of my system. And then data placement. As I mentioned earlier, we have the ability, and I'll touch on this briefly, of being able to cache and bring some of the data from the constellation of data sources into your front end if you see a need for that. So this is kind of what I've been talking about is sort of the capabilities as far as data virtualization today on the Big SQL platform. What this diagram tries to depict is really where we are today, what are our areas of investment, and really where we're looking at in terms of the future. So in green are the capabilities that are available today, I mean, we continue to invest across the board in all of these capabilities, don't get me wrong. But there are some that we are particularly focused on. The blue ones are the ones that we're actively investing. For example, we're constantly looking at what is the need for new data source connectivity out in the market and gradually, slowly adding those connectors. Definitely we have a very rich sort of command line interface to our systems, but customers obviously, I mean, users like graphical user interfaces, so we're investing heavily in that area as well. And in terms of APIs, enriching the ability of applications to consume the Virtualize solution. Now the areas in red, those are the ones I wanna spend a few minutes on, and I got 5 minutes to go, so I'll go quickly. Caching, very important, right? Now, caching can be done today in the Big SQL platform. So we're probably one of the few, if not the only engine out there that gives you a wide range of capabilities in terms of caching. For example, you can cache data in what we call local tables inside the DB2 engine, fully transactional. You can cache data in HDFS. You can cache data from your constellation of data sources in either HDFS or DB2. So what cache to use, what storage to use, is really up to you. And that's one of the challenges today, that this, our implementation of caching focuses on materialized query tables, on MQTs. And today these MQTs are user-driven. And so you have to decide when to create them, what data, what storage to use, and also what is the life cycle of those MQTs. When does the data become stale? When do you have to recreate the MQTs? In terms of a full, complete data virtualization solution, we don't think that that is good enough. So really where we are taking this is to the next level. The system should be able to figure out by looking at your workload, what should I be caching? Should I be caching anything at all? Should I be caching query results? Should I be caching table data? Should I be caching partial table data, right? And what is the optimal storage for the system to use? And once I've created these MQTs, what is the life cycle of those MQTs? Essentially, it's making the caching autonomic. That is our view. And in terms of distributed query execution, certainly this is an area where one of the competitors in the market, one of the other vendors at Denodo, talks heavily about this, is really being able to leverage the compute capacity that you have in your constellation of data sources for distributed query execution. If you want to get the performance, you have to tap into that compute capacity that you have. Today and up until now, certainly with Federation technologies, much of the work happens on the front end. You push down as much as possible query execution to the data sources. But truth is that you have, if you look at the compute capacity, if you're looking at an ecosystem with hundreds or thousands of databases, the compute capacity out there in that constellation of sources is in general much larger than your front end. So being able to tap into that compute capacity by doing parallel execution of your queries, distributing the execution of the queries across the constellation is very important. So we're looking at very innovative technologies built on open source to help us do that, right? And another fundamental aspect that people often forget as well is for this system, especially when you're looking at a vast constellation of data sources, the system has to be fault tolerant, it has to be reliable, it has to be resilient. What happens if you're executing a query that is joining from 10, 15 data sources, and one of them hits a hiccup, there's a hiccup on the network, or you're not able to get all the data? So the idea is to be able to specify in your query results what we call data fidelity, right? So there are cases, usage scenarios, where getting data that is not 100% accurate, but maybe 90%, 75% is good enough. So the user knowing what the degree of data fidelity is very important. So this is another area that we're exploring in terms of our virtualization layer. And this is just a sort of very high-level overview of, again, kind of our vision. This is where we're going with the data virtualization layer and with Big SQL really as a platform for realizing that vision. So at the top is your front end. So it's a Big SQL engine running on Hadoop, on segregated storage. Really, your storage could be on Hadoop. It could be an object store on cloud somewhere. Information governance and metadata. I didn't talk about that, but that is fundamental in any virtualized environment. Key really to the implementation of an effective logical data warehouse. And then over the network, you access your constellation of data sources. And worth highlighting are these things these blue circles called remote agents. This is what I was talking about in terms of, there are customers that certainly in terms of their usage scenarios, they do have tolerance for us being able to deploy some compute capacity on the data sources themselves or adjacent to them. And let me give you an example. So we have a customer that has a number of data centers dispersed across the globe, right? And they have, I think, 2 in Asia, 2 in Europe, and 2 in North America, right? And if you recall earlier, I was showing you the example of the 2 Oracle tables, right? Where it makes more sense to bring the data to the front end rather than push the analysis. Well, when you have to take into account network latencies of moving that data across the world, then it may not be such a bad idea to actually try to do the joins and the aggregation closer to the data sources where there is geographical proximity. And to be able to do that, this is the technology built on open source that we're looking at to be able to leverage. So this is kind of our vision. This is where we're going with the data virtualization from where we are today, and we're hoping to make some announcements later this year in terms of availability of this technology. And I guess time's up. Sorry.
So this kind of summarizes, the whole Big SQL, what it brings to you. So it has no vendor lock-in. So what it does is it brings Db2 to Hadoop, and it enables you to, exploit all the rich capabilities that Db2 brings to you, and also work with your open source file formats, and it interlocks very closely with Hive Metastore. So you can always, keep all your data in HDFS and query using Db2 Big SQL. And also one of the core capabilities to be able to query Hive and HBase together. So if you have streaming data coming into HBase and you have your analytics workloads on Hive, you can use Big SQL to query against those. And of course, if you have been at the keynote, machine learning and AI is where we are going in the future. So we are going to, with Big SQL, you can operationalize your machine learning model. So once the model is built, trained, and tested, you can bring it to Big SQL and use Big SQL to feed the model with all the data that's disparate and operationalize the models. So Big SQL is a tool that gives you many capabilities, and it brings you closer to your AI ladder. So you can access data that's anywhere. You can do powerful analytics, complex queries, and your workloads, and also have very good performance for those workloads. And of course, you can operationalize a machine learning model using Big SQL, and that gets you a step closer to the AI ladder that we are working on. Thank you, everyone. I think we're running out of time, so if there's any questions, we'll be outside so we can take it out there.